Alright, so Mike is asking, can you show me how to get the backtest Renko bars to open a trade at the open of the bar instead of the close of the bar in Raven? Let's see. So Mike just needs some clarification. So a bar type, bars cannot control whether a trade gets executed at the close or at the open of a bar. Bars have nothing to do with that. So that's a setting called calculate on bar close. Alright, so let's bring up Raven. Alright, so just for some clarity, I'm going to open up that moving average here. Right, so I brought up the indicators window here, and you'll see every indicator and every strategy has this calculate on bar close. Alright, so that's the setting. So if you're wanting to wait until you get the opening price of a new bar, basically you have to have this set to false. But you have to have it set at false for your strategy. So I'm just showing you in the indicator list, but really, if you're running, let's see, yeah, you do mention Raven. Okay, so in Raven, so let's see. So here's a bunch of sample strategies, and you can see, let's see, where is it? Yeah, well, let me add it here. So you can see even strategies have this calculate on bar close, right? All these sample strategies that come from NinjaTrader have this calculate on bar close, right? So in Raven, so this calculate on bar close is underneath the general section. So everything from the general section on down is added by NinjaTrader. So these are all NinjaTrader parameters here. So these don't come from Raven, they come from NinjaTrader. So there's your calculate on bar close. So if you want to wait until the bar opens, you set this to false. So when it's true, NinjaTrader waits for the bar to close and then it does its calculation, right? So if you set it to false, that means NinjaTrader will calculate or it'll update Raven every time a tick comes in, right? Every time a tick comes in, then NinjaTrader will keep updating Raven. It'll keep recalculating it. So that's how you get your strategy or your indicator to update in real time on the bar that's actually building. So, alright, so that calculate on bar close, right, you can see that the, my moving averages only calculate to the bar that's closed, and they don't calculate on the bar that's actually being built. Right, so, let me modify the white one here, set it on false. And so now you can see the white moving average is now calculated on the bar that's actually being built there. So let's get my data feed going. There we go. Okay, so with Raven, I'll just set that to false, and then so when you set that to false, that doesn't that's not going to prevent it from calculating when the bar closes, and it's not going to lock it so that it only calculates when the bar opens. So Mike, whether the So really it depends on your on your BloodHound system whether the trade's going to execute at the at the open of the bar, or halfway in the middle of the bar, or towards the end of the bar. Really, obviously, when you have this calculating on bar set defaults, your trade's going to fire off basically based off of price movement, not whether you're at the open of the bar, midway point of the bar, or towards the end of the bar. It's just going to be on how far price moves, and is it enough to trigger meet your trade requirements, your BloodHound logic to fire off a trade. So all right, so Pathrawin, hopefully I'm pronouncing your name right, has a question about bringing up the SI starter pack and loading it into Raven. So all right, yeah, you bet. So let's see if I even have the starter pack on here. I'll close up BloodHound, and let's bring up Raven. All right, so I can see that. So here's a little note. So this is BloodHound's interface. You click on File, you'll see that there's a quick list here. So these are going to be. This is a quick list of the most recent BloodHound templates that were most recently opened and saved. So the starter pack's not on here. So if you don't see what you're looking for on here, then just use the open option there, just like any normal program. And let's see, doesn't look like I've installed the starter pack. Let me just double check here. So the way you can tell if you have the starter pack installed is you can go to your Windows program list, and you'll see it'll say starter pack on here, and that was not installed. So alright, give me a moment here, I'll get this installed. So just so you guys know, this starter pack is not a trading system, okay? This is something that's more of a training tool. This has not been built to be a trading system. Basically the starter pack consists of common trading concepts, that are taught out there in the wild. So the starter pack has templates that show you how to build, or they have pre-built these concepts, but they're not refined by any means. So let's see. All right, I think that did it. So all right, let's pull up Raven again. There we go. All right, there's that file. We open it up. All right. So let's go to the logic template. And all right, so you see there's 5 different common systems here. So we got a midline pullback, a momentum, a squeeze trade, a mean reversion system, and a breakout system here. So if you want to test one of these, we'll just test the top one here, the midline pullback. We'll select that one. All right, so there's the system. So we'll click OK to get that loaded into Raven. All right, So now the entry signals, right? We'll select the midline pullbacks as the one that we want to analyze. So there is no exit logics with this starter pack, right? So this is a starter pack just to kind of be more. Well, I mean, there's two ways you can use this starter pack, right? I mean, you can use it and you can analyze the logic to help you learn. I know a lot of people are better at back engineering something when they're learning stuff, especially if someone's learning to code. A lot of people who are learning to code like to look at existing code that someone else has written, and then they read it and they kind of back engineer it into their mind, to learn. So, if that's the type of learning that you like to do, then this starter pack is perfect for that. Because you know exactly what type of system the starter pack, each logic template is building, and so you can just look at the solvers, and all the nodes that's in that system to help you back engineer it and learn what it's doing and everything. All right. So I was saying there is no exit logic. These are just entry signals only. All right. So I'm going to leave limit orders off. So we're just going to submit a market order just so we can get the signals. All right. If we're going to back test, guys, this is key. You need the start auto enabled. That needs to be set to true so that it does start. So that Raven does start enabled. So that way the back test mode opens up, right? So when this is set to false, you see the back test mode is missing. Set this to true, the back test mode appears. So, if you want to see the chart trader or not, you can turn it on or off. One thing to note about NinjaTrader, right? So Raven can submit an ATM, but NinjaTrader cannot backtest an ATM, right? So ATMs are not backtestable by NinjaTrader. So we'll have to leave it on default to at least get some kind of initial backtest results. So let's just do something simple like a 20 and 20 stop loss. If you want to use a trailing stop or not, you can turn it on, and we'll just turn this thing on, and we'll generate some initial results here. And so there we go. There's some results, and let's see. Let's before I get into the performance, let's take a look at what's on the chart here, right? So I have up at the top of the chart here, right? I have BloodHound, which is the black text, right? So this is today's workshop in BloodHound. Raven is the orange text, right? So Raven, I loaded up the SI starter pack. So down here on the chart, we can see there's a BloodHound down here on the chart, and there's Raven down here on the chart as well. All right, so we can see the signals coming from Raven down here. Right, we can see that this long signal here lines up with this starter pack long signal, and this short signal lines up with the starter pack short. And at least right here, it looks like if you just reverse these trades, you'll be in good business. Let's see there. So there's a couple more trade signals. So there's a short that was successful, and a long that got in too soon. But anyways, just wanted to point out the fact that I've got BloodHound on the chart and Raven on the chart at the same time. So do keep that in mind, and keep them separated in your mind. So and if you want to pull up the performance report on that, that's what you can do. And so I think I've only got 5 days of data on my chart, so the last 5 days didn't do too well. And like I said, these are not trading systems. All right, so don't trade them as is. If you want, you can take them and refine them, and add your own tweaks to them to improve them, to hopefully make them profitable. But they're not ready to go. They're just a starting idea to help you learn how to use BloodHound, and help you learn how to program in BloodHound. So I kind of jumped to the end and just showed Pathralwyn how to put that into Raven. But you'll notice that my chart, I've just got couple of my 2 moving averages that I have on there for every workshop, and I've got my stochastic and this thing, and these indicators have nothing to do with that midline pullback template here. So let me show you how to pull up the chart properly, pull up a chart for this midline pullback so you have the correct indicators on your chart. So let's see, I'll just minimize that for now. Let's pull up the other chart. Here we go. Alright, so if you want to pull up one of those starter pack templates with all the indicators loaded on correctly, just go to pull up a chart, go down here to templates, and we're going to load a chart template for that starter pack. So let's see, it's probably going to be way down here on the bottom for me. Yeah, here we go. They're all the way at the bottom. So we have starter pack breakout, mean reversion, midline pullback, right? So I just showed you the midline pullback. So let's load up that chart template. And there we go. As Ninja thinks about it, there. Okay, great. So let's see. Let's take a look at the indicators on here. So we have a Keltner channel. So that midline pullback uses a Keltner channel. It has an EMA and it's using an RSI. So you can see the various indicators that are being used. Right, and of course, and that chart template does load BloodHound up, so we can see BloodHound on here giving us the signals, right? And so when you have the correct indicators on your chart, the signals make a lot more sense. So as it says, it's a midline pullback, so when price pulls back to the midline of the Keltner channel, that's what's generating those signals, right? So the concept of this generic trading idea is when price pulls back to the midline, we're hoping to get a bounce off of it, like so. And then if you want to learn about BloodHound, we can open up BloodHound, click on the button, and then we can go to the Logic tab. Let's expand this all the way, and you can see all the logic nodes and everything, and function nodes and the solvers that put this together. So Daniel Rowe built these for us. So if you guys aren't familiar with Daniel Rowe, he is a excellent BloodHound system builder. So he's built a lot of systems for the BloodHound customers, and so this is a couple of or I guess this this is 5 kind of common trading systems that Daniel's put together for us, to hand out to you guys. It's kind of a training tool for you guys. So. Right, so you can look through all the solvers. Daniel took the time, and he's labeled these solvers pretty well. right? So if we look at this solver to know what the solver is doing, well, it's looking at the Keltner channel with a 20 period, and it's looking at the midline slope, right? So the name of these solvers should give you a good idea as to what it's doing. So this solver here is looking at the closing price inflecting, right? If you don't know what an inflection is, basically it's a reversal point. So when something reflects, it's reversing. And so when it comes to charting, you know, it's like right here, when it comes to charting, each of these little reversal points on the RSI is a inflection point. All right, so an inflection on a chart basically just means reversing down or reversing up. So, right, so you can take a look through all these solvers, you know, read the name, that kind of gives you an idea as to what they're doing. So, and if you want to take a look at, one of the other ones, like say the momentum one, then what you'll want to do is go back into your templates, and we're going to load the template for the momentum system. Alright, so starter pack momentum. So there's my chart template. Click OK, and that'll put all the correct indicators on your chart for the momentum system. So there we go. And so it looks like the momentum's using the MACD and a linear regression at the same time. Interesting. So now we can open up BloodHound again. Go to the Logic tab, and then we can see that we have our entry momentum selected, and so here's all the solvers and function nodes that make up the momentum system. Let me get back to Don's question here about the RSI. So let me load up, let's see, which one was that? Yeah, okay, there's our RSI. So Don was asking, can BloodHound identify these reversal points here? So let me put, yeah, let's see, let me put a little marker on there. You know, so can BloodHound identify these little reversal points? And yes, it can. I'll see if there is anything in here doing that already. No, it doesn't look like there is. So this RSI, let's see. So in the starter pack, the RSI, we're looking for the RSI to be below 40. Yeah, below 40 for a long signal, or above 60 for a short signal. So this isn't looking for those reversal points. Yeah, all right. So let's go back to our chart here. So this is the chart for today's workshop lesson. So let me load up today's BloodHound template. There we go. Okay, and let me get the RSI indicator on this chart. I'll try and match it up with the this other chart. Let's see, what do we have here? 5 and 1 is the RSI settings. Okay. So let's change this RSI to 5 and 1. Alright, looks a little similar. And so I'll go into BloodHound here. So I'll start working on the logic tab. I'll make a new logic, and we'll call this the RSI reversal points. So let's grab a inflection solver here, connect it up, and then let me give this a proper name here. So it's RSI using 5.1 settings. Okay, so now last step is to put our RSI in here. So let's swap out that SMA and put an RSI in here. So let's change our RSI to 5 and 1. Alright, so we have the RSI plot selected for us. So we're not using the average, we're just going to use the original RSI plot. Click OK, and there we go. So definitely a lot of reversal points there done, but if I stretch this out, right, so we can see we have a reversal point up, and then we get a long signal, and then when it reverses down we get a short signal. Alright. Let's see. All right. So starting with the function nodes. So in the following weeks to come, I'm going to go through each of these function nodes one at a time. So the inverter node's pretty quick. If I get through this really fast, then I'll cover the inverter and the long-short modifier today. So let me create a new logic template, and we'll call this the inverter node. Let's drop it on here. Alright, so I guess just to start off with, function nodes won't generate any signals by themselves. So function nodes were built to modify, adjust, manipulate signals that come from solvers. Right, so the function nodes don't do anything, don't generate anything onto themselves. They're just there to manipulate or adjust, modify signals that come from solvers. So the inverter is one of the more simple ones. It simply does what it says. It just inverts the output here. So let's see. I've got this little indicator that I built, and all it does is just put little long and green markers on the chart. Kind of looks a lot like BloodHound. It gives you a positive one or a negative one. So I just built this just so I can demonstrate how the function nodes work. It really doesn't have any other practical purpose other than to help me kind of illustrate how these function nodes work. So I'm going to build a threshold solver. Connect that in here. And I'm going to set the indicator to that signal generator. And I'm going to match the settings that I have on the chart. Alright, so we'll use the long plot to generate a long signal. I'll use the short plot to generate a short signal. Now, you'll notice there's nothing coming out of BloodHound, no output yet. And that's because with the threshold solver, there is no default output setting for the threshold solver. You'll see they're all set to 0. So this is the one solver where you do have to go in here and select the output that you want to see. So in this case, I'm going to set my outputs like this. Long is going to be greater than A. This short is going to be less than E. So now we can see BloodHound matches my little indicator here. Alright, so now let's take a look at what the inverter does. So inverting is different than reversing a signal. So let's see here. Take a look at this. So as we take a look at this long signal, if we look at BloodHound's output, see, inverting gives you the opposite of, it basically just returns the opposite. So we can see we're getting long signals when there is no, when there is no long, condition from the indicator, and when there is a long plot on the indicator, the output is now missing. Right. So if we look at the threshold solver, right, we have a signal that matches the indicator, and if we look at the invert, right, there we go. Right, so even with the shorts, we can see the shorts are inverted here. So, so that's kind of the core function of what this inverter can do. But another, let's see, so I'm going to rename that. So you can name your function nodes to tell you what they're doing. So this function node is doing a invert. So let me grab another function, another inverter. So here's another way that you might need to use this inverter. So I'm going to rename this to long only. So I can plug this in, and so what I'm going to do is, since this is labeled long only, what I'm going to do is I'm going to disable the short side. So I'll turn the enable off. So now you can see there's only a long signal coming out, right? And it's an inverted one, but I'm going to, on the long side, I can turn the invert off. So now all I get are long signals. Right. So you can use the inverter to isolate, long signals only or short signals only, coming out of something like that. So let's grab another one here. So let's just set this up real quick. So we'll disable the long side, and we'll turn the invert off for the short side, and there's our shorts only. Alright, and now there's one more additional function that this guy can do. Hopefully you notice on the options it has a swap function. So this is a way to reverse your signals. So instead of inverting them, you can actually reverse them. So let me add another function node down here, another inverter. Let's plug that in. Alright, so I'll just call this swap or reverse. And so what we want to do is I'll turn this on, and it's not swapping yet, although you will notice. So let's take a look here. Let me stretch this out. So look back to these two guys, right? So I've got the little dot and the diamond. So this is turned off. If I turn this on, you'll notice, see how things look different now? So now actually the long signal disappeared. And that's because it was swapped. But that's really not the practical use I wanted to show you. What I really want to show you is if I turn the invert off, now we can see the more practical use. So this is a way that you can reverse your signals. So sometimes you'll need to take a solver's output and you need to reverse it. So so instead of getting a long signal out, you actually wanted a short signal instead. So this inverter can be used to swap or reverse your signals around. So and it's a good idea, to kind of put a name, to name your function nodes just the same way that you name your solvers as well, so that way you know what that function node is doing. So even though this guy's been renamed to swap and reverse, it still tells you up on top, what this function node is. So unfortunately, if you do rename a solver, you pretty much just have to look at the settings to find out what the solver is. So because this little top area for solvers, this little top label area is actually used for the multi-time frame stuff. So you can identify what time frame a solver is on. So let me alright, so that's just looking at the signal generator. I'll just name that guy. So those are the practical uses. Just kind of going down the list here. So enable, disable. If I disable it, then basically it doesn't do anything, We can see the output just disappears now. If I disable it, turn it back on. So swap, you should know what that is. It's just a way of, if I turn it off, then basically this inverter is doing nothing now. It's not doing anything because it's not inverting, It's not inverting, and it is allowing the long and the shorts to go right through. So I just get the same result as looking at the threshold, If I turn this off, so swap just reverses the signals. So to the long side, I can turn off the long sides. There we go. We can see the long signals disappeared. So remember, this is swapping. So the short signals here. So these short signals turned into the long signals. Turn that back on. So there you go. Long signals are back on. And of course, the invert. So we can invert those long signals if we want and get some weird results. So, right, and of course, same thing for the short side. So, yeah, the inverter is pretty straightforward. Not much to it. Let's see. Yeah, we've got enough time. We'll dive into the long-short modifier there. All right. So let me make a new logic template. All right. So just so you guys can see, I've got 3 logic templates now. So. Alright, let's put a long-short modifier in here. And let me put that same signal threshold solver on here. Alright, so there's our signals that we're working with. Alright, so they're going to match this indicator here. And oh yeah, you'll see sometimes we're going to get a long long and a short on the same bar. Alright, so let's take a look at the long-short modifier. Alright, so the long-short modifier has a bunch of different modes. So these modes will manipulate, the signals coming in various different ways here. So the default one is swap. Alright, so this solver is basically giving us, right, a long and short signal when price is reversing. So using these Ranka bars, it's easy to see where their price is reversing. Alright, so let's take a look at swap mode. Alright, so we're using swap mode here. So we can simply see that when price reverses up, instead of getting this long signal, swap mode just reverses. So I already demonstrated that in the inverter node. So, but we have a bunch more other modes here. So we'll go through them one at a time. All right, let's go down to the next one. Mirror long. Okay, so the mirror long. Let's click on the solver. On the function node. So okay, so mirror long mode. So you'll notice. Let's stretch these bars out a little bit. Right, so we're getting a long and a short output whenever price reverses up. Right, so remember the solver is giving us a long signal here when price reverses up. Right, so to look at the original solver, there's our long signals with our arrows. Let's put a down arrow there for the short signals. So mirroring long does literally what it says. So it's taking the long signal from the solver and it's mirroring it, so which generates a short signal. So you get both a long and a short signal. So generating both a long and a short signal at the same time could be handy if you're using the if-then node. Generating a long and short would be handy if, say, like you have some kind of condition that has to happen before any trade takes place. So this imaginary condition doesn't tell you the direction of the trade. This imaginary condition just has to happen before you can even take a trade. Doesn't matter if it's long or short, but it has to happen. So if you have some kind of trading rule that has to happen first before you can take, either a long or a short, then you'll need a long and a short output at the same time, right? So if this condition doesn't know the direction of the trade, you need both a long and a short output at the same time. So getting this long and short output at the same time would allow both a long and a short trade to happen. So that's kind of one common reason why you would need a long and a short signal from a solver. So this function node can help you achieve both long and shorts, to allow both a long or a short trade to happen. And then of course your other conditions would filter out whether it becomes a long trade or a short trade. So that's kind of one of the reasons why you'd use mirror long, or you might need to mirror the short side. Right, so now you can see when where we have the short signals coming from our solver. Let's plug our solver in again. Right, so these short signals now are the short signals being mirrored. So now you get a long and a short whenever the short signals come out. Alright, so that's what mirror does. Actually, how about if I'll just call that mirror. Alright, let's go to the next one on the list here. Okay, average. So average is gonna take so the average is gonna add. Let's see. Let's stretch this out. I'm gonna stretch this out a lot now. Okay, so I've locked the scaling now, so that way we can see the long and the short, and the zero line is right in the middle. All right, so where we have these arrows, right? So we have, I'll just work with this over here. All right, so on the long output, we have 1. Let's stretch that over. There we go. So we can see we have a 1. So our little flag here identifies a 1. Now the short output is 0. So if we take the average of 1 plus 0, the average is 0.5. So if we take a look at the output here, and let me give this a name. Alright, so what the solver is doing is it's giving you the average of the output. So as we look at this bar now, the long output is 0.5 and the short output is 0.5. Right? So basically we got a long and short output. That's the average of the long plus the short, and it just averages it out. So it's just doing a simple mathematical formula for you, right? All right, let's grab another one. And maximum. All right, we'll do maximum. All right, so the maximum is going to return the maximum value from either the long or the short side. So if the long side has a maximum value, it's going to return, you know, the value of the long side at its maximum. Let's see, you know, I guess to really kind of start demonstrating this, let's see, let's move the stochastics up here. So these mathematical stuff kind of gets into the fuzzy logic a little bit, but we can see that basically what it's kind of doing here is whenever we get a signal, you know, it doesn't matter if it's a short or long signal, that maximum mode is returning the maximum value of that signal, right? So right, our solver is returning 1 for the short and a 1 for the long. So the maximum mode is returning 1 for long and short, you know, anytime we get a signal here. So if we get into the fuzzy logic stuff, let me build a solver to kind of demonstrate that. starting to run out of real estate here. Alright, let's take a look at this. Alright, I'm shrinking the scaling of my stochastics here. Okay, so I've locked the stochastic so we can see 100 and 0. So let's see, let's back up here. So okay, so our stochastics is maxed out at 100 as our Renko bars are going up. And BloodHound's output is 1 as well. Now look, as we step forward, so you see as the stochastic starts to dive down to 90, and then BloodHound's output goes down to 0.9, right? And so here we go. BloodHound's output, we can see the long output begins to dive down. So our stochastics is at 54. BloodHound's long output is at 0.54. And we can see the short output is starting to increase as our stochastic comes down, like so. Right? So basically I generated a solver that kind of gives us a varying long and short output based on our stochastics. So I want this kind of variable output to help demonstrate what the maximum solver is doing here. So when our stochastic is up near 100, remember our long output was maxed out at 100, and so the maximum mode is returning the maximum value here. So as our stochastic, dives down towards 50, the output starts diving down towards 50, 54. So, and then our stochastic goes lower and lower, but if you remember, this short output was increasing. As the stochastic approached 0, the short output was increasing. So let's take a look at the original solver. So you can see the short output here, how it's increasing. So the maximum is going to return 0.697 because it's a greater number than 0.3. So if we took a look at our maximum solver, so we can see the short side and the long side equals 0.697 because the short side had a greater value than the long side, and so the short side had the maximum value. So that's what the maximum mode is going to do for us. All right, let's go on to the next one. And minimum mode. All right, so as you guys might have guessed, now in this mode you're going to get back the minimum value. So, which is obviously the opposite, the mathematical opposite of the maximum. So we can see here when our stochastic is maxed out at 100, we were getting no short output. So 0 was the minimum value coming from the short output. And then right here on this, you can just barely see an output there. And so as the stochastic dived down, the short output started to give us just a little bit of an output. And as the stochastic dived down towards 50, remember as it dived down towards 50, the short output was giving us the smaller value. So, and now that our stochastic is below 50, if you remember, the long output was giving us the smaller value, or the minimum value. So let's take a look at the original solver, right? So the long output here the long output here is giving us the minimum value of 0.26. And so 0.26 is what the minimum mode is returning. All right, let's move on to the next one. And let's see, product. So this simply is just going to do a math, a multiplication. So product is multiplication. All right, so going back here, so remember when the stochastic is maxed out at 100, there's 0. The short output was 0. Let's just take a look here. Right, so there's no short output, it's set to 0. So 0 times anything equals 0. So, right, so the solver is going to return 0. So, and then as the stochastic dives down, right, the short output had a really small value. So you take the short side times the long side, and you end up with these really, really tiny values here. And then as the stochastic dives down towards 50, where, at least, so now you have, at here you have, let's see, on this bar you have 0.54 times, times well, actually, let's take a look. Take a look at the solver. Oh, okay, so we have 0.54 times 0.45. We'll round it up, 0.46. So when you multiply those two values together, that's what you get, 0.25 when you round it up. So, right, simply just doing a multiplication. This kind of has a practical use. I'd say that I do use this product once in a while to isolate a long and a short output. Let me try and think of let me think of a solver I could put together for you guys to illustrate that. Yeah, okay. I think I've got an idea. I'm just going to build it real quick. I'm not really going to go and explain what I'm doing in detail. I just want to build this real quick. Yeah, perfect. Okay, let's take a look at the output here. Okay, so you notice how sometimes you get a long and a short output from the solver. So let's say you wanted to isolate only the bars where you get a long and a short output. So you're building some kind of unique special condition, and your solver tells you when that condition happens when you get a long and short output. Right, and actually I guess I might as well explain here. So I'm sure you guys are probably curious. So let me throw an SMA on the chart. SMA 14, it's going to be white. Okay. And yeah, so we get a long and a short output on the same bar when the low of the bar is below the white SMA and the high of the bar is above the white SMA. So in other words, when this white SMA cuts through the middle of a bar, when it's touching a bar, I'm getting both a long and a short output here. So I'm getting a long output when the bar is completely above the white line, and I'm getting a short output only. Hopefully you can see this right here. So there's a short only when the bars are completely below the moving average. But if the moving average touches the bar, I'm getting a long and short. So let's say you want to know when when a bar touches a moving average, and that's our condition. So I built this solver, and so when I get a long and a short output on the same bar, that tells me that the bar is touching the moving average, and that's what I want to know. So what I can do is disconnect that guy, connect that up, and so when I use product, right, when I multiply, so if I multiply 1 times 1, I get 1, but if I multiply 1 times 0, then you're left with 0. So this is how you can identify when a bar is touching some kind of a plot line. So in this case, it's a moving average. But this plot line could be any indicator that you guys might use. So, right, and this bar right here, it has a little wick on it. It's hard to see that wick, but there is a wick on that bar. So the low price of that wick actually touches the moving average there. So that's why we got that one little bar there. All right, so that's a common use for the product, is a situation like this. All right, let's see. There we go. Give this solver some kind of a name here. So when the bar touches the SMA, there we go. All right, let's see. I think we're done with product. So let's see what's next on our list here. Addition. All right. Yeah, simple enough. Let's actually with addition here. Let's go back to our closing price inflection, right? So we got all these inflection point whenever the bars reverse. So let's say we want to just identify any kind of bar reversal. Just to identify all bar reversals, but in a non-directional way. So if I use addition, so now I get both a long and a short whenever the bar reverses on me. Right, so it's simply just adding the long plus the short, and that's what you get. So let's see, let's take a look at so remember this solver here that's looking at our stochastics, right? So stochastic dives down, the long output's diving down, but the short output's getting greater. So if we look at the addition of that, and actually the way that solver is built, yeah, we're always going to get a 1 on the output. So actually that solver is a bad example. And yeah, that one's a bad example. So we'll just stick with the closing price example here. All right. So that's a fairly common use of the addition. So the addition basically is doing what the mirroring is doing. So remember, if we go back to the mirroring is only going to mirror. It's only going to mirror a short or a long. So let's say you wanted to mirror both, either one. It doesn't matter if you get a long signal or a short signal. You want to mirror either one. Well, you can use addition instead. Instead of using mirroring, you can use the addition. So, all right. Time to shrink everything up here, pull it all together. All right, let's grab another function node. Let's see, difference. Okay, well, this is simply just subtraction here. All right. All right, I'm going to see if our stochastic solver does anything, if that works for this. Yeah, okay, that makes sense. So let's focus in on this area here, right? So we're subtracting these two values from each other. So we're subtracting them, and so let's see when. Yeah. Okay, so when our long output is close to 0.5 and our short output is close to 0.5, right, we're going to expect to see like 0 or something close to 0. So let's take a look at the subtraction formula. And we can see that our output is almost at 0. And over here on this bar, let's circle this. So this bar, we almost have a 0 as well. And if we look at the signal coming into it, yeah, so the long output is 0.54 and the short output is 0.45. So subtract those together and you do get nearly 0. Let's take a look at that function node again. And, yep, so our output is 0.08, right, so almost 0. So difference is just doing a subtraction between the two. I can't really think of a practical use for that, but it's there in case you need it. All right, next one on the list, divide, simple division, right? So once again, I'll use the stochastic solver here. All right. All right, so so as the input values get smaller, when you're dividing them into each other, it gets smaller as well. Let's see, let's see what some of these others do. Here we go. Yeah, so remember this one with when the bar touches. So sometimes you get long only, sometimes you get short only, and sometimes you get both. Let's take a look here. And all right, so division is a little tricky. You can't divide by 0. So it's going to be the short side divided into the long side. So where there's no output, right? So where there's no output, that's telling us we had a short only from the solver. Let's connect the solver up. Yeah. All right, so just a moment. Let me draw a little square. So we had a short only there. Right, we have a short only on this bar. So now let's take a look at the solver. So when the short side is set to 0, there's no output. Now when the long side, when there was a couple of bars over here that were long only, and let's mark these guys. So there's our long only. So if you take 1, divide it into 0, you know, you really can't do that, but you know, you get a division error, but you know, you do get 1. So and of course the other bars, let's see, yeah, this bar, and this bar, we had a long and a short together. Yeah, so here we go. Draw, there we go, circle both of those. So 1 divided into 1 still returns 1. So, and the last one is none. You know, none really doesn't do anything, just turns all the modes off. So if for some reason you needed to turn all the modes off temporarily while you're doing some testing or some checking, right, you can turn your nodes off. You can turn the mode off, you know, and then put it back to a mode. So and you can also use this solver to isolate long and shorts like I did with the inverter as well. So let's grab another one here. All right. So we can use the long short modifier to create a long only as well. So I can set this to none and then disable, turn the short side off, and there we go. And so now we only see when the bars reverse up, right? So I eliminated the bars reversing down. And trying to shrink my chart back up. Oh. There we go. So there's the solver signals going into that function node. So we can see I got shorts, and I can just turn, you know, one of the sides off, you know. So if I want shorts only, I can turn the long side off and generate a short only. So all right, let's put it back to long only. There we go. So well, and that does it. So we've gotten through all the various modes. Yeah, I don't see any questions on that. So I guess with that, we'll wrap this up.